We were able to obtain this data table from the study. The first thing we did was make a new data table that was in terms of years past the starting year of 1986. From the new table, we made a graph in order to better visualize trends in the wolf population throughout the years. Our variables were P, wolf population, and T, time in years past from 1986. From the data, we were able to find wolf population as a function of time represented by P of T.
The first trend was from 1986 to 1988, where there was a parabolic decrease from 15 wolves to 14 wolves. Since the trend was parabolic, we had to use a quadratic equation to get our P.
The second trend was from 1998 to 1990, where there was an exponential increase from 14 wolves to 33 wolves. Since the trend was exponential, we had to use an exponential equation to get our piece.
The third trend was from 1990 to 1992, where there was a parabolic increase from 33 wolves to 41 wolves. Since the trend was parabolic, we had to use a quadratic equation to get our piece.
The fourth trend was from 1992 to 1994. There was an exponential increase from 41 wolves to 48 wolves. Since the trend was exponential, we had to use the exponential equation to get our part.
The fifth trend was from 1994 to 1998, where there was a parabolic increase from 48 wolves to 49 wolves. Since the trend was parabolic, we had to use a quadratic equation to get our piece.
The sixth trend was from 1998 to 2000, where there was an exponential increase from 49 wolves to 64 wolves. Since the trend was exponential, we had to use an exponential equation to get our piece.
The seventh trend was from 2000 to 2002, where there was a constant increase from 64 wolves to 108 wolves. Since the trend was constant, we had to use a linear equation to get our piece.
The eighth trend was from 2002 to 2004. There was a constant decrease from 180 wolves to 59 wolves. Since the trend was constant, we had to use the point-slope formula to find the slope, then we used the linear equation to get our part.
The ninth trend was from 2004 to 2006, where there was an exponential increase from 59 wolves to 167 wolves. Since the trend was exponential, we had to use an exponential equation to get our piece.
The 10th trend was from 2006 to 2007. There was a constant increase from 167 wolves to 230 wolves. Since the trend was constant, we had to use point-slope formula to find the slope, then we used the linear equation to get our parts.
Our domain was 0 is less than or equal to t, which is less than or equal to 21 because the study was done for 21 years. Our range was 10 is less than or equal to p of t, which is less than or equal to 230 because the lowest the wolf population ever reached was 10 and the highest it ever reached was 230. We have 10 different breaking points in our graph. Each time the data trends changed, we had to have a new piece that would better suit the data. Our function is continuous because there were no interruptions in monitoring the wolf population.
Created using Powtoon.